Wonderful. All right. So thank you everyone for joining us today. I'm Sandy Moskovitz. I'm the program director at SWAN. And today we are thrilled to be hosting, along with RiSWP, the Rising Smart Water Professionals, the AI Masterclass. This is the 21st episode of our mentorship series. So thank you to all of us for being with us on this journey. We're really excited to see how it continues progressing. So just a first quick introduction. So any of you who'd like to add in addition to your name, your organization to your name, so we know who's joining us. And maybe if it's anyone's first time joining a mentorship series, if they want to just say hi to the audience, introduce themselves, feel free to take yourself off mute, or you can just say hi in the chat. That also works really well. Anyone, or everyone's being shy today? All right, so just so you guys know, SWAN is the Smart Water Networks Forum. We are the leading global hub for the smart water sector. And this event is co-hosted alongside RIF's, SWAN's Young Professional Division. That's all about really boosting, sorry about that, young professional participation in the smart water sector and creating the future leaders of tomorrow. So we're really excited to have you all here with us today. In addition to this mentorship series, RISP also runs events throughout the year. So we would love to see any of you at any of our events and participating in our different initiatives. We have a career development program and portal, which we'll share the link here with you guys shortly. We have some different smart water courses and workshops we host 2 a year, with our most recent one being just now in Vancouver at the 14th Annual SWAN Conference, with the second one always being in the fall. We'll host it virtually, so as many of you from around the world can join us. We also have this mentorship series, which this is a part of. And then, of course, our ambassador program, which is a year-long leadership initiative to really help grow the smart water leaders of tomorrow. So that we announce nominations for it in the fall. So stay tuned for that. And then if you're interested in getting involved in any of these events, feel free to reach out to any of our leadership team members. A few of them are here with us today on the call. See you guys in the audience. Jade, Boitumelo, Maddie. You guys want to say hi? And then also, speaking of our leadership team, we're going through a bit of a transition this summer. So we're going to have 2 openings available on the RISP leadership team. So any SWAN members out there in the audience who really feel a call towards building young professionals and helping boost young professional presence in the water sector, this could be a really, really great opportunity for you guys to get involved. Again, feel free to reach out to myself or any members of the leadership team if you have questions, and we'll be accepting nominations until July 31st. And then just a few more announcements. So we had a giveaway for our SWAN conference. So congratulations to Priya, who won a virtual pass to join the event. We hope that you enjoyed yourself. And then speaking of the events, I don't know if anyone who's here on the call with us was just at SIWW or at the SWAN conference. Maybe someone wants to share what their experience was like at one of those events. Not to put anyone on the spot, but if you had any thoughts, quick takeaways you wanted to share, I'm sure the participants would be really happy to hear about that. And maybe that would encourage them to attend their next water sector event that maybe they were shy about going to. They felt that young professionals might not be noticed in the crowd. If anyone wants to share, sorry about that. Anyone wants to share their experience? Jade, you around?
Yeah, I can share mine. Hi everyone, I'm the chair of the RiSWP leadership team. I attended the SWAN conference. It was my first time attending the conference, and I also work full-time remote. So for me, it was awesome to just see human beings' faces and interact one-on-one. And I think especially I've spoken to a lot of people in this risk community online. So it was great to meet other young professionals interested in the same thing in person. So that was my highlight, making friends. And then also just realizing how much cool stuff is happening out there, getting the chance to talk about smart water, connect with other people was an absolute highlight. And I hope I get to go for many more.
Thanks, Jade, for sharing that with us. Anyone else want to share about their recent experience at an in-person smart water event, SIWW, or maybe a different event that you attended? There's so many out there. I know we can't make it to all of them as much as we would like to. Or feel free to drop some comments in the chat if you don't want to unmute yourself. Moving on. So I'm going to hand it over. Today's also a very exciting day because we have a new host for our mentorship series. So I'd like to present our new host, Boitumelo, who is also a member of our leadership team. So she can share more about herself, about the show, and about our guest mentor today. Thanks, Boitumelo. Happy to have you on board.
Awesome. Thanks, Sandy, and welcome again to everyone. My name is Boitumelo. I am based in South Africa. I work for a company called Talbot, and I currently work as the Analytics Business Unit Manager. And I'm also part of the Swan RiSWP LT team. So I think Sandy touched a bit on what we do at RiSWP. One of the things that we do is the mentorship series. So the purpose of the series is just life and career advice from the best in the smart water network. So it's usually a set of interactive questions. So we interview the best in the sector, and we try to have these monthly. All of our mentorship series are recorded and published on our RiSWP page and the Swan website. So if you've missed a few, you can always go back. We also have a few that are available on YouTube. And then just some housekeeping rules for those that joined us a bit late. You are allowed to introduce yourself and where you are from in the chat box. As our guest is going through his presentation today or segment, you are allowed to ask questions. You can post them in the chat box. At the end of the segment, we will allow you guys to ask questions. If you want to unmute and ask a question, you are welcome to do so. If not, you can just post it in the chat box and we will ask it for you. And without wasting any more time, I am just going to get into it. Our guest speaker today is Matt from Centtech, and our series today is about AI. So we will be having a nice AI masterclass. So it'll be a little bit different from what we usually have, where it's an entire session of just Q's and A's. Today we'll have a bit more fun. So we have a 30-minute segment on AI that Matt will do above us asking him a few questions about himself. So just a little bit about Matt. I believe that he will, when he starts talking, tell us a little bit more about himself as well. So Matt is an academic and biologist by training. He has spent the last 4 years working as a consultant, helping industry clients get to grips with and derive value from their data. He is currently the Asset Health Program Lead at Sand Technologies, contracted to Thames Water in the UK. So Matt, welcome. Thank you so much for joining us today. Can you tell us a little bit about your journey into AI and the water sector?
Absolutely, with pleasure. Thank you, Boitumelo. Please excuse my voice, everybody. I'm recovering from a cold. I know it sounds like something being shifted over gravel. I apologize for that. I hope it's bearable through the call. Thank you very much for having me. Firstly, Swan and RiSWP, it's a great pleasure to be here. I have had a few engagements with various parts of Swan over the last 6 or 7 months, and they've all been hugely enjoyable and interesting. And so I'm very, very pleased to be here again. My journey to where I am now is a fairly unconventional one, I think. While I'm talking a little bit about that, I'm going to ask a favor, actually, of everyone on the call. I have a slide deck in mind, lined up, and I have some specific themes that I intend to focus on as I talk, as we move into the AI section of the call. But I can tailor that as we go. And the drivers of that would be the specific interests of people on the call and the backgrounds of people on the call and where you all currently sit in your businesses. So broadly speaking, and I'm aware that this is going to be a bit of a generalization thing, but I would be hugely grateful if you could put yourself either in kind of digital analytics, AI, maybe let's put it this way. Let's say, is your primary interest or the route that you took to get here through data, or is it through water and wastewater? So my favor is, or my request is, could everybody put either data or water and wastewater in the chat so that I have some idea of where you're all at and how you got here, and can make sure that the direction that I take the conversation a little bit later is going to be appropriate. Cool. So my journey to get here, as Boitumelo said in my short bio, I am a biologist by training. I studied zoology and botany at university and was on an academic track. I did a PhD in ecology. I then jumped across into archaeology for a little while and did a postdoctoral research fellowship looking at stable isotope analysis. So it's using biochemical traces to track nutrient flow in environments. And what I did was look at some currently living animals and some late Stone Age humans down here on the Cape Peninsula near where I live, and tried to work out if there were dietary similarities across the two, where they were feeding at the interface of the marine and terrestrial environments. So looking at land-based animals or people who were going down to the seaside and feeding on marine food sources. And after that, with having had a great experience in that space, I moved back into biological sciences. I lectured for a few years and then was coming to the end of a contract and decided, partly because the contract was ending and partly because I was ready for a change, that I would like to move into industry and try something different. I mostly self-taught myself, or taught myself Python, and then managed to get a job as a junior data scientist working for a tiny consultancy here in Cape Town. I was contracted to a beverage manufacturer and distributor, worked on some interesting problems there, but realized that for me, although I enjoy data, I enjoy solving problems using data, the domain in which I worked is actually hugely important to me. And so I started kind of considering other opportunities, and a friend of mine who worked in the utilities vertical at what was then Explore AI, and which has since been acquired by Sand Technologies, said, I think you should speak to my boss. There's a link to biology here. There's a nature ecosystem complex problem link, and I think you'd be a good fit. That was in August, September of 2021. I joined what was then Explore AI in November of that year, and have been with the company since. As I said, we were acquired by Sand Technologies towards the end of last year. And I've been in the water and wastewater space that whole time and have found it to be a hugely engaging domain to be in. I think the problems that require solving are many and varied and complex. And I truly believe that bringing data and AI-driven solutions into that problem space could make a huge difference and add huge value through time going forward.
All right, well, quite interesting. Thanks for that, Matt. What do you believe has been the most impactful AI project that you've worked on, or data related? Doesn't have to be AI.
Sure. So I'm going to cheat a little bit in answering that question, in that I'm going to talk about a project that I haven't directly worked on, but I've worked alongside, which has been in our smart waste, the smart waste part of our engagement with Thames Water, where we've worked on two tools called DAM and SLAM, standing for Discharge Alert Manager and Sewer Level Alert Manager. And essentially what these tools have done is integrated data from somewhere in the region of 20,000 sensors across an entire wastewater network, pulled that data together, overlaid some intelligence on it using models to predict risk across the network, and then fed that to users in a control room in a manageable way. So one of the things that I see as hugely valuable about using data and digital solutions that integrate and leverage data is the scale at which they allow people to operate and the scale at which they allow people to think. So if you have 20,000 sensors and you have data flowing in a continuous stream, as a person, it's incredibly difficult to actually process all of that information. But if we add a layer of intelligence, add some rules, add a machine learning model, and in that way scale down the cognitive load of the user, then they can start to make better decisions at a bigger scale and therefore deliver more value.
All right, thank you. Speaking of projects, I know that in the water sector, we have people that are data enthusiasts and some that are not. So what has been some of the challenges with introducing new projects, data related to utilities?
That's a great question, Boitumelo, and very, very diplomatic segue, I should say. So I think one of the biggest challenges is that it doesn't matter how good the solution is that you build, it doesn't matter how smart it is, how much AI you have. If no one uses it, if no one trusts the output from it, then it's not going to deliver value. And so one of the things that I think people often underestimate is the difficulty and the extent of change management required in building the solution and then actually getting buy-in from users and stakeholders within the business and getting them to use it. And that's the one thing that I would encourage people to think about upfront, because what we find is that if you can take people on the journey with you, if you can show them at regular intervals what data you're using, how you're processing it, get their input on those things and try to make sure that they understand what you're doing and you understand what they're doing so that you surface the right insights, then you're setting yourself and your users up for success, because they then understand the tool, understand the approach taken, and almost without exception will have greater trust in it.
All right. Thank you for that. So I could ask questions for days, but in the interest of time, let me allow you to get into the AI segment. And once you are done, we will use the rest of the remaining time for further questions. And like I said earlier with the audience, anyone that has questions while Matt is speaking, you're welcome to type them in the chat box. And when he's done, we'll just we'll open the floor for questions. Thanks, Matt. Over to you.
Cool, no problem. Thanks, Boitumelo. So I would really like this to be an interactive session. I'd like it to be a conversation. Please, folks, you're welcome to interrupt me, unmute, ask a question, or you can pop something in the chat. I currently can't see the chat, so let me move that across to my other screen. And I will mostly be looking across at my second monitor, so please excuse me not looking straight into the camera. It's purely for that reason, and I will try and check the chat every now and then. So that's my email. If anyone would like to contact me after the call, please feel free to do so, or you can find me on LinkedIn, either way. The other person who's on this intro slide, James Combrink, helped me run this session at a previous Swan event, actually, at the Smart Metering Workshop in Cape Town. And he helped me put the deck together. So I've left him on the cover slide just to give credit where it's due. James is also someone who loves to engage with people and chat through problems and challenges and solutions in the water and wastewater space. So I'm sure if you felt so inclined, I'm sure you wouldn't mind if he wouldn't mind if you dropped him an email or got in touch on LinkedIn. Okay, so as I said, this is built on a session that we ran at the Smart Metering Workshop in Cape Town. And with that in mind, we started with this data context. If you have 1.2 million households in a service area, and you manage to put a smart meter on each of those households, and those smart meters were taking a reading every hour, you would accumulate 10.5 billion data points per year. That's a huge amount of data coming in at a very rapid rate. As I said earlier, one of the things that I think about in these spaces is the scale of data processing, the scale of decision making, and expecting a human or even a few humans to process 10.5 billion data points even across a whole year is very challenging. So my question to all of you is, how do you solve this problem? What is an approach that you might take, or a principle that you could apply? Feel free to throw something in the chat or unmute and just say an answer out loud. Automation, standardization, use AI from Eamon. Okay, so anyone else feel free to add more, but that is the answer we would propose. As a company, this is the space we like to play in. So the question is artificial intelligence. I see many of you are more from a water wastewater background than a data background, so I'm really intrigued to see what answers we get here. I'd like you to please put in the chat, what is the first word that pops to mind when you hear someone say artificial intelligence or AI? Algorithm. Yep, that's a good technical answer. Reduced man hours. Ooh, I like that. Going into the problem space. Automation, decisions made by the computer machine, automation, machine learning. Yep. Okay, cool. I see some thumbs up coming in. Yes, those are all, from my perspective, quite sensible things to associate with this. Using data to make decisions, absolutely. More time to innovate, very nice. Okay, so thankfully, I'm not seeing anyone throwing in Terminator 3 or Robot Apocalypse or anything like that. So I don't feel the need to address that sort of fear. I was thinking robots, haha, right, Jade? Okay, so it's out there. It is out there. There is some fear, there's some uncertainty around these things. And part of what I'm going to try to do over the next 20, 25 minutes, indeed, ChatGPT 5, what I'm going to try and do is make this all a little bit less scary and show you, especially those of you who haven't necessarily been specifically data driven or data focused in your thinking, how you might be able to start to think this way, and in so doing bring extra value to your companies or your clients or whomever you work with in trying to solve problems. I do want to share a PDF, and I had hoped that I could do so in the chat, but I realized that you can't attach a file. So I'll have to just talk through it just now. Unless Sandy or Boitumelo or Jade, you have a way that we could quickly circulate a PDF to everyone. You can think about that and speak up just now if there is one. If not, no problem.
I think I might be able to attach a file. Yeah, like there's a third icon from the bottom. So there's like format, smiley, like emoji, and then there's a file. I don't know if it's available to everyone.
Oh, yes, sorry, that is available to me. Apologies. So I'm going to quickly load something in the chat. It's a PDF, so I hope everyone will be able to download it and view it. So the title of the more structured section of this evening's session is AI and You, an Introduction. For any of you that have not come from just a data background, but a data science background or computer science or AI, please feel free to comment. Please feel free to add to what I have to say. I'm quite happy to get input from others as well who are in a position to provide that. And I've just realized I didn't update the date on this. Apologies for that. Okay, so first of all, we're going to talk a bit about terminology. What is AI? What is data science? What is machine learning? What is a model? How do all of these concepts relate to each other? And I'm going to do that by building out a picture that will ultimately be a Venn diagram that I hope will be intuitive. So to start with, artificial intelligence, or AI, is the ability of machines to make decisions and take actions associated with biological intelligence, typically humans, us. So that's a broad decision, and the complexity of how the machine does that is up for debate. You will see variations on this definition in different spaces, but this is the one that we're going to start with. Then within artificial intelligence, if we exclude, for example, rules-based decision engines, we move into the machine learning part, the subset of AI that is machine learning. This might be supervised, unsupervised, or reinforcement learning, and that speaks to the types of data that you might feed into the models in question, as well as the subset of algorithms that you could potentially apply. Supervised learning is where you have labeled data. So you have input data that is defined, you put some sort of model in place, and then you have output data that is also defined. So you tell the model what the output should be. Then you have unsupervised models, machine learning algorithms, where you don't specify that output, you don't label the data, you don't say, this is what you're aiming for, model. You just say, here's the input, model, I want you to find the patterns in the data and surface those patterns for me. And then finally, reinforcement learning, which involves specifying a model that tries different actions or different decisions, and certain types of outcomes that might come from those actions or decisions are rewarded and certain ones are penalized. And so those actions or decisions that are not penalized are reinforced. And so the model learns as it goes. Please stop me, anyone, if you have questions, if any of this is unclear. And then again, as a subset of machine learning, we have deep learning. And this is when we move into hugely complex models that replicate neural networks. That's what the name comes from. The implication is that it's a sort of stylized replication of what might happen in the human brain. It's a whole series of decisions being made with different mathematical weights for those decisions along the series of nodes, if you will, within the neural network. And so what this all requires, once you're in the machine learning and deep learning space, is a modeling approach. This is how AI is enabled. And there are three typical steps here. Training the model. So you take an algorithm, which is a data agnostic structure. You then put that together with some data, and you train a model, a specific version or specific printout, if you will, from that algorithm that defines the relationships in the specific data that you're looking at. Then you test that model. So you use some data that the model hasn't seen before, and you check how good the model is, how good the model performance is. Does it predict well on data it hasn't seen before? Is it generalizable to other types of data? And you can use different performance metrics to check that. And then finally, you deploy and run your model. And that's, of course, when you really start to realize value. If you have a model that is built but isn't feeding into any sort of front end, isn't being seen by users once it makes an inference, then you're not going to get value out of it. So that third step is hugely important. This is the fundamental concept. For all those of you who are a bit perhaps fearful or uncertain when it comes to data and data-driven processes and versions of AI, the fundamental concept that I invite you to take away from this talk is input, model, output. If you're approaching this from a water and wastewater centric perspective, the complexity of the model, in a sense, is almost immaterial. You will likely have a data scientist or some sort of implementation specialist who needs to worry about that. what I would argue you should be focusing on is the input and the output. What's the data going to be that feeds into the model? And what is the output that you're looking for? What is the output that will allow you to make better decisions in your business problem space, will allow you to derive value from the data that is fed into the model? And then alongside and partially overlapping all of this is data science. So data science is really the study of data to extract meaningful insights. This might involve machine learning, it might involve deep learning, but equally it might not. It might be a relatively simple statistical test that allows you to test a hypothesis, working through the scientific method, and then generating meaningful insights that deliver value from the data. And finally, to round out our collection of buzzwords on this slide, we have big data, which often underpins these things, especially, for example, when it comes to deep learning. Deep learning models, they're hugely complex and they have they require a lot of data. And that actually means that sometimes they're out of reach of certain businesses or business units. If the data is not in place to support a hugely complex model, then it would be an ill-advised action to try and use a complex model. So that's something to be aware of. The foundation under all of these things is data. Certain types of these things, it should be big data, which comes in, there's six V's of big data: velocity, volume, veracity. So it's not just how much data you have, it's how good that data is in terms of quality, it's how fast it's coming in, and so on and so forth. Are there any questions on this slide? I know there's a lot going on there. I've thrown a lot of information at you. Would anyone like anything clarified or a comment?
I can ask a question quickly.
Yeah, sure, Boitumelo.
You spoke about big data and different types of models. Is there a lot of thought that goes into the type of models you choose when looking at things like computational time? I know that there was a big buzz about ChatGTP and that it uses a lot of computational time, probably because of the number of people that use it. And because of that, now the servers require large amounts of water to be cooled down. So there was that disadvantage that ChatGTP is actually just consuming too much water.
Yeah, absolutely. So that's a very good point. Complex models take a lot of time to train, and they can even take quite a lot of time to generate inference. And time is money, energy, and water. If you're running any sort of data center, as Boitumelo just said, ChatGPT, for example, I forget the statistic, but I know that someone has done the work, has done effectively the data science to translate X number of ChatGPT queries into Y volume of water that gets used up through that process. So yes, absolutely, that's something to consider. Your implementation person, your data scientist, maybe some of you are data scientists in this space, should certainly be thinking about that. The water use, generally speaking, is going to be fairly far removed from the user, from the client, from the business that you might be working for, but energy and associated cost probably aren't going to be. And so it is worth realizing that if a simpler model can do the trick, if the data is not there to support a really complex model, or you could do either one, but the simple model's performance is actually comparable to the more complex model, maybe you actually want to go with a simpler model. It's quite a complex space and there are lots of moving parts to consider, and the one you raised is certainly one of them. Any other questions or comments?
Right, there's a question in the chat.
Yes.
Is computer cooling systems are typically closed loop, so they're not really consuming water. Is that correct?
And I see that Eamon has done me a
Thanks.
favor and answered the question
Yeah, awesome.
in the chat as well. Yeah. So my understanding is that they're sort of semi-closed loops. And so as Eamon says, there is evaporative loss and much like with a power station, for example, where water is used for cooling, the water that gets pumped out may be quite warm, and so going into a river or an ocean has a problem, and or might have contaminants that have now, I want to say enriched the water, but that's clearly not the right word, affected the water, and so that water going out, because it has to be moved out at some point, becomes potentially an environmental hazard. Thanks for chipping in there, Eamon. I hope I'm pronouncing your name correctly. Well, there we go. Search cycle of concentrations to see the mass balance. And the other thing that you could Google is ChatGPT water use. There have been some really thought-provoking articles published recently on that. Okay, I'm gonna forge ahead because we don't have a huge amount of time left. So, as I said earlier, input, model, output, that's what I'd like you to think about. So a model is a mathematical articulation of the relationship between inputs and outputs. The input is going to be data, information is data, it's in data, whatever the form, and we find features from it. It might be structured data in the form of tables. It might be unstructured data in the form of images or video footage, which is really just a whole lot of images put together, or sound recordings. We then take some sort of model and bring it into the space. We quantify patterns from a straight line to the complexity of a human brain. Any of you who did introductory statistics courses through your studies would probably be familiar with this. It's ordinary least squares regression. It looks at the relationship between two variables that can be relatively well defined by a straight line. Moving from that into more decision tree type models, we can look at defining decision boundaries, and these are just effectively a series of if-then statements or questions that get asked, defining different groups in the data, and you can overlay multiple decision boundaries into your data space, and that can help you quantify, for example, characteristics of, if this was a housing question, houses that are more than $1 million, roughly $100,000 or $10,000, and that might relate to customers in a water and wastewater space. And then finally, neural networks, which are used, for example, to process and generate inference on unstructured data, such as a picture of a cat. So if you were looking to classify this picture, what type of animal is this? It would need to go into a neural net type model, convolutional neural network. There'd be a bunch of training that would define the relationships between that cat and a prediction, and then you would run that model. And then finally, you come up with a prediction. In this case, our model is clearly not a very good one because it is telling us that the picture is of a rabbit. So something has gone wrong in the training exercise. And the prediction could be a house price modeling. It could be weather models, insurance models. ChatGPT is just a model. It is coming up with a probabilistic prediction of the next word that should appear in a sentence or a paragraph of text. Applications and trust. I know that this is something that's very important. It's receiving a lot of airtime in the water and wastewater sector. Before looking at specific applications, I'd like to talk a little bit about how we view machine learning and AI and what it does, broadly speaking, when we apply it in a given problem space. And our answer to that is that it advances human capabilities in volume of information processing, speed of operation execution, detecting complex patterns, objectivity, and repetition without degradation. And those, I think, touch on a lot of the things that you all put in the chat when I said, what comes to mind when you think of artificial intelligence? And for this reason, in my mind anyway, I'm actually starting to quite often think of AI not just as artificial intelligence, but as augmented intelligence. So if you bring in a model that does this for a human operator, it helps them process more information more quickly with more complex patterns. In a sense, you're putting a human together with potentially some sort of really complex model and coming out with almost an augmented intelligence type situation. When it comes to specific applications, we can use modeling approaches of varying complexity to look at predictions through time or space. In this hypothetical instance, we're looking at a time series model. We have data up to a certain point for a given quantity, and when we move beyond that point in time, we need to start making predictions. Then we have anomaly detection. Again, data is coming in thick and fast. You have a control room user who is getting hundreds, thousands, millions of data points a day that they're trying to manage. If what they're really looking for is unusual behavior in the processes that are being monitored, we can start to look for anomalies and flag those, only those to the user, rather than all of the data coming through and them trying to process them. Language processing, the classic example is ChatGPT. Many of us are familiar with that, but that is effectively a highly sophisticated chatbot in a sense, although I'm sure the ChatGPT creators would not appreciate me phrasing it that way. But if we bring that home, if we bring that back a few steps, you could think about automating customer engagements. If you work for a water and wastewater utilities company, there are many things that could be automated when it comes to engaging with customers, such as circulating their bills and then dealing with an initial cycle of complaints, that first layer potentially. And then finally, something like clustering, where you might not necessarily know what. So this often would be an example of unsupervised modeling, where you have, let's use customers, you have a whole lot of customers, you have maybe data around property size, the number of people who live on that property, the proportion of that property that is garden versus house, whether or not that's a pool. And if you don't yet have good metering data, you could potentially start to cluster those customers based on, to an extent, demographic data, but also characteristics of their property, and possibly start to generate meaningful insights around predicting behavior of those customers based on what their property looks like. I'm going to breeze through this because of time. Trust and transparency are hugely important. I know that Boitumelo wants to ask another question around this, so that's partly why I'm going to breeze through this. Interpretability and explainability are slightly different things. Technically, they sound like the same or synonyms of each other, but in this context, they aren't quite. Interpretability is, how does the model work? So if we use a car as an analogy, interpretability is, what are the engine parts? How do they generate thrust if it's a combustion engine? What are the cylinders? What are the pistons doing? How does each step of the process work? Explainability is what drives the model output. So the model output, using my car analogy, is the car goes forward when you put your foot down. So if you put your foot down, you then end up with the car moving forward. In the same way, with a model, if you adjust a certain feature, if you have values around a certain feature, you can start to say, well, if the input changes in this way, the model output will change in this way. But that's different to understanding what's happening in that model box in the middle in terms of the actual mathematical operations. That middle piece is the interpretability. And then accountability is, accountability is looking at regulatory compliance, explaining, validating, and documenting your modeling approach. So I think we have a few minutes for this, but maybe rather than splitting into breakout groups, let's just have discussions here. Gilberto, I'm going to come back to you on your question a little bit later, if that's all right. I'd like to get through these last few bits of discussion and then come back to the Q&A. So what I'd like each of you to do, either unmuting or through the chat, is think up a potential modeling use case from your own work context. And I'm going to take you to I don't have it open. Give me 1 second. I'm going to take you to a different slide to just help drive this a little bit. And the PDF that I shared has that Venn diagram and some of those definitions on the one page, and on the second page it has this, because I'd like you to take this away from the conversation today. I think it is an intuitive and hopefully helpful step-by-step plan to move from understanding or thinking about your business problem through the process of grappling with the data, grappling with potential solutions, and then also thinking about how the output of an AI-driven solution might be used and how it might deliver value. So does anyone just off the bat have any recommendations for a problem that they have encountered in their work environment, a business problem, where they think maybe a modeling approach could be useful, or one that you've seen that has been implemented that has worked really well?
Data gaps is seems to be, especially when you've got so many data points coming from, and you've got what was the first question, like millions of them. If there's gaps in the data, this question comes up a lot at work.
Can you elaborate on that a little bit, Madeline? So
yeah, so if you had a bunch of meters, smart meters, for example, and they're reading every hour.
Yep.
Sometimes the technology is not reliable, and then you have missing values.
Got you.
In that data set. And when that, especially when the battery operated technology, the batteries starting to run low, and there's maybe like the odd gap error every now and then.
Yeah.
If you amalgamate that, I mean, averages is fine, but if you amalgamate that and there's a lot of data gaps, that can be a bit of an issue at times.
Yep, absolutely. And maybe you have millions of data points coming in from thousands of sensors. A relatively simple bit of coded logic could potentially pull out those sensors that have not sent through a signal, if we're talking about smart meters, that have not sent through a signal for X amount of time. And if you can surface that on a front end that is intuitive and user-friendly, then your user can go in and say, okay, there's something wrong with these sensors. Let's send out a team to investigate whether it's a battery or damage to the sensor or whatever the case may be.
Yeah.
Yeah, great example.
I think another example I've come across is that of preventative maintenance of pumps. So early fault detection, and it assists you to be like more proactive in terms of planning your maintenance instead of waiting for your pump to completely die and you have like unplanned shutdowns.
Yeah. Yeah, absolutely, Boitumelo. So predictive maintenance, that's effectively time series modeling. You have maybe a vibration meter or something that tracks temperature of the pump when it's in operation. You feed those, when you train up a model, you feed those into the model, and it starts to realize that when vibration levels exceed X or temperature exceeds Y under given operating conditions, that's indicative that the pump is going to fail soon, and that allows you to take proactive action. Okay, I see we've got 9 minutes left. I don't have a super hard stop at 5 BST, so for the record, I'm okay to carry on for a little bit, but we've got a couple of other things to cover, so I'm going to jump back, and if anyone else wants to throw examples in, we can loop back to those examples a little bit later. I'm going to jump back to this. Okay, then just as a sort of thought experiment, feel free to go away and think about business problems that you think might have huge value if there was a way to leverage data or solve the problem with an AI-driven solution, but you don't know if it's possible or you don't think it's possible. Feel free to put that maybe in an email and we can have a chat, or pop me a LinkedIn message and we can think through that, and maybe there's not something off the bat, but it's always fun to think about these things and try and find hypothetical solutions. Cool. So I'm going to stop there in terms of sharing my screen, and I know Boitumelo has a few more questions that she'd like to ask.
Yeah, I think we can start with the questions from the audience in the chat.
Sure.
Try to open that quickly.
I'm happy to just, no, you go for it, Boitumelo, or I can read them off if you'd like.
Yeah, you can do that. That's okay. As
Okay,
well.
cool. So Gilberto, you go ahead.
Oh yeah, I've got them now. Do you have recommendations for anomaly detection algorithms? I've seen many used PCA, ICA, where is it now? ICA, auto encode, decode, etc.
Yep. So first off, I'll say that I haven't done a huge amount of work in anomaly detections, so I'm wouldn't consider myself an authority on that specific type of solution, but the ones that you've mentioned, I know are in the mix. When it comes right down to it, depending on data availability, even something as simple as a mean variance model can be useful, provided you are factoring in some of the contextual information. So having a flat kind of threshold line around the typical mean of, say, pump output might not be particularly useful. But if you start to look at typical patterns, or pump output's a bad example. Let's say you've got sensors in your water network. There are likely to be variations through the day in terms of typical behavior for those pumps. If you have high resolution data, you can work that into your algorithm, whatever your algorithm is going to be. And as I say, we found that in some cases, even just a mean variance model that brings in some contextual information can be really useful.
All right, thanks, Matt. And a question from Mohammed. In clustering, how do we predict the right cluster for a random point? Like in value prediction, we have equation y equals to mx plus c. We apply this equation for a random x value and we get the prediction y. How is that going in clusters?
Right. So the clusters will be defined, and there are various algorithms that can be used for clustering. One of the most common ones is called k nearest neighbors, which essentially defines those clusters based on where the points sit in the data space. And it's kind of possible for a human to do that relatively intuitively if you're only dealing in 2 dimensions, if you only have 2 input fields. But as soon as you start to get to 3, 4, 5, 6 dimensions, it becomes almost impossible. But the model will look at, it'll generate the clusters that essentially minimize the differences between the points in those clusters. And then when you make inference on a random point, it will use the data characteristics that define that point to place it within one of the clusters that have been defined. I hope that makes sense, Mohammed.
Yeah, I hope it makes sense, Mohammed. Question from Jade. I'm wary of being an AI enthusiast who thinks AI is the solution to every problem. Are there any suggestions or rules of thumbs for when not to apply AI?
Great question. So, rule of thumb, if the data is not in place to support an AI-driven solution, don't try and force the AI-driven solution. The other thing is going back to the definition of AI. If we keep that relatively broad, we can look at, for example, rules-based algorithms. And my colleagues and I at Sand Technologies have a sort of philosophy around this, which is we focus on the business problem and then choose the right solution for the problem. We don't come to a problem space with a pet solution that we want to implement and shoehorn it into the problem space. So one can derive value from data without AI. One can support business decisions and business actions using data without having quote unquote AI in the solution. I think that's something to bear in mind. But broadly speaking, or the broadest rule of thumb, I would say, is you need data in place. And if the data is not there, it's going to be very difficult to generate a really useful AI or data-driven solution.
Right. Thanks, Matt. Another question from Aman. Is there a document report that collects practical and feasible AI-powered solutions for water and wastewater utilities? I'm looking for actually implemented solutions that I can get managers excited and a bit less skeptical.
That is
managers, yeah.
Yeah, that's a very good question.
Mm-hmm.
And I'm actually going to swing this in across the table, I guess, I'm not sure. I know Swan has a huge amount of resources. I know that Swan has white papers and a whole lot of stuff on the website about different types of approaches used in the smart water network space. Sandy or Boitumelo, do you know if there's a kind of service provider agnostic resource that could be used, could be consulted in this vein?
I know that Swan has a lot of very cool case studies. You can add on, Sandy. So if you go to the Swan resources, you'll find a lot of cool case studies of projects. Some just data driven, some have some AI in them. So you can look at what people have done and what lessons they've learned from them. So I think we have a whole lot of
one step
I don't know
ahead.
if
There you go.
something from. Yeah, I see Sandy just sent the link there to our resources. We have a lot of cool case studies where people have used data in their utilities, and there are a lot of lessons that have already been learned. So yeah, that was a cool question. I don't see any other questions from the audience, and just in the interest of time, I think I'm gonna cut mine short. I'm just gonna ask you two last questions, Matt. Is how do we ensure that AI implementations are ethically sound and environmentally sustainable?
Very good questions. In terms of ethical soundness, this is a hot topic. And so AI practitioners should be aware of the risks, whether that's you or someone that you're working with. You should always be looking out for bias in the data sets, because bias in the data will lead to bias in models. And so there's an ethical component there. And then, of course, there's privacy of data that one needs to watch out for in terms of ethical considerations. So there's a lot of legislation around this in Europe, for example. GDPR is in place. In South Africa, I know we have the POPI Act, the Protection of Private Information, I think POPI stands for. So that's something to look out for, or two big concerns. And then remind me, Boitumelo, what was the second part of your question?
We need them to also be environmentally sustainable.
Right. Yeah. So that's a tricky one, because I think it depends on the scale at which you're considering this. If, for example, you use energy and water to train and run a model to generate inference, it's using energy and water in one space, but it has the potential to save energy and water in another space by making processes more efficient. I don't have a silver bullet answer for that question in terms of the environmental sustainability. of a given model other than to say, factor it into decision making around the model that gets chosen, because a simpler model is going to typically take less time to train and therefore use less energy and less water than a complex model.
All right. Thanks, Matt. And then my last question to you, just some advice for young professionals. What advice would you give young professionals looking to make a mark in this field? And are there any particular resources or networks you would recommend for those starting out?
Sure. So what would I recommend? I think there are now huge repositories of resources online that will take you from being a data novice or a data skeptic to being a competent practitioner and anywhere in between. It's worth thinking about how you want to engage with these things. Do you want to become a data scientist? Do you want to become an analyst with those sorts of capabilities within your business space? Or do you want to become somebody who understands these problems and can talk the language and understand the concepts, but not necessarily build these types of solutions yourself? Ask yourself those questions before you go and engage in the online space and start trying to find resources, because the types of resources that you should focus on and the depth to which you should dig into them is going to be determined, or should be determined, by the answers to those questions. There's so much out there that you could very easily get lost and kind of go down rabbit hole or wormhole after wormhole and not actually find what you're looking for, or derive real value from what you find.
All right. Thanks, Matt. That was my last question, but we have one more question from the audience. How can AI algorithms predict when a pipeline segment is likely to fail based on historical data and real-time sensor readings?
Sure. So good question, Solomon. Thank you. Thanks very much. The simplest approach there, or perhaps the ideal approach there, would be you have labeled data. So you have data that has shown what's happened previously with sensor readings that have occurred just before or at the same time as pipeline failure. So when a pipeline is burst, that's likely to lead to differences in the behavior, or maybe even just as it's about to burst, it's likely to lead to differences in the behavior of the flow, the pressure, the level, whatever the case may be, of the liquid in that pipe. What a model will be able to do, if you then have the failure data, is link those two, determine the pattern that's present in the data, and when it sees that pattern down the line, say, this is what happens in the data just before a failure or as a failure occurs. And that will then give you either a little bit more warning, so you can proactively go and try and manage it, or it will flag it potentially before it would otherwise be flagged. So let's say it's a water mains burst that starts underground and it takes a while to surface. Humans will only pick that up when the water surfaces, or if there's a downstream effect where customers lose water supply. The model might be able to reduce that response time by saying there's been a change in the behavior of the water in the network. Go and have a look at it. Go and start to mitigate the risk.
All right. Thanks for that, Matt. Thank you, everyone. So we went a little bit over time. We apologize for that, but this was such a great session. At the beginning of Matt's talk, he did share his contact details. So if you have more questions, you are welcome to contact him on LinkedIn or via email. You are also welcome to get in touch with us on our LinkedIn RiSWP Swan page. You can just join there and ask us additional questions. So without wasting further time, I'd just like to thank everyone for joining and thank Matt for giving us his time. I hope that everyone learned a lot today, and yeah, we'll see you next time. Thanks, everyone.
Brilliant. Thanks all. Take care. Bye.
Thank you, guys.
Thank you.
Thanks, Boitumelo.
Thanks,
Thank
everyone.
you.
See you.